All right, guys, here we go. Pre-calculus, chapter 12, section 2, homework page 833, techniques on evaluating limits. Okay, use divide out and rationalizing technique to evaluate limits of functions. Okay, we want to take limits when it's a strange situation, basically. When a limit of x approaches c gives you 0, 0, what do you do? Okay, so techniques on how to deal with that. Okay, ideally you want to factor and then take a new limit, or rationalize and then take the new limit. Okay, so the idea is the limit of a function is when the left side, okay, as x approaches c, a number from the left side equals limit 1. That's the left side limit. Okay, and then limit as x approaches c plus, which means on the right hand side of the limit, the limit is L2. That's the right side limit. Okay, so basically left hand side and then right hand side, they're gonna be two limits. Okay, if these two limits are the same, then the limit as x approaches c of the function is that limit. Only if and only if, that's what IFF is, if and only if the left and the right side are equal, then the limit exists. Okay, hopefully you understand that. All right, so let's do some examples. Okay, so for example, do some examples here. Limit x approaches 2, x squared plus 2x minus 8, x minus 2. Okay, again, let's try it out. We plug in 2. Okay, 2 squared plus 2 times 2 minus 8 over 2 minus 2 is 0 over 0. Okay, so when you see that, that's no good. Okay, so now we got to go back. We got to go back to the original problem and see what can we do with this problem. And try factor it, rationalize it, and we notice here it's factorable. So x plus 2, x plus 4, x minus 2. On the bottom, x minus 2. So now we notice that these cancel out. Now it's going to be limit as x approaches 2 of x plus 4. So we get 6. See, whenever you get a 0 over 0, that's something to be aware of, okay? And that tells you you should be able to factor it or rationalize it and get the new limit, okay? Okay, so let's say, for example, limit as x approaches 0, square root x plus 9 minus 3 over x. I think we did this one on last section, but it's reversed. No big deal. Okay, again, we plug in 0 and we get 0 over 0. Again, when you get this, that's something to be afraid of, okay? Something's wrong. All right, so what we want to do is rationalize this. Square root x plus 9 minus 3, x, okay, multiply by the top and bottom, okay? Rationalize it, x plus 9 plus 3, square root x plus 9 plus 3. We'll multiply top and bottom by, again, what's called the conjugate. Remember that? Okay, so on top now is dots. So x plus 9 minus 9. On the bottom, x plus 9 plus 3. So when we simplify this, we get x over x, square root x plus 9 plus 3. Now, what we know is these guys will cancel out. So now we can take the limit as x approaches 0 of 1 over square root x plus 9 plus 3, which is going to give us 1 over 6. That's my limit. Okay? So that's going to happen. Okay, so for example, limit as x approaches, let's say, negative 1, x squared minus 4x plus 5, x plus 1. When we plug in negative 1, we get, let's see here, plug in negative 1. negative 1 squared minus, oh, that's a minus 5, sorry. 4 times negative 1 minus 5 over negative 1 plus 1. Again, we get 0 over 0. Scary, okay? So what does this mean? Well, let's see. Is this factorable? And it is. X minus 5, x plus 1. On the bottom, x plus 1. And again, we notice that these will cancel out. So now it's going to be really, once we simplify, it be limit at x approaches negative 1 of x minus 5. Now we plug in negative 1. We get negative 1 minus 5, negative 6. Okay. Now, there are times when, like for example, unfortunately, there's going to be no limit. Okay, like this guy right here. Limit as x approaches 0 of absolute value x over 4x. Okay, so this one, unfortunately, is not going to have a limit. Okay, so when we look at this, because this is absolute value, you can't really factor anything like that. So let's try this. What happens when x approaches 0 from the positive side? Okay, so again, here's the number line, here's 0, here's the positive side, this is u, and you're walking towards 0. Okay, so pick any number going towards 0. Okay, so you know, negative, let's say positive, sorry, x equals 0.1. Okay, you're going towards 0. So let's plug in 0.1. Absolute value of that on the bottom, 4 times 0.1. So you get 0.1 over 0.4. And so this gives you 1/4. Okay, limit as x approaches 0 on the negative side. Number line, here's 0, here's the negative side. Again, this is u. You're walking towards 0. Okay, so as you approach 0 from the left side, you're going to reach a number like negative 0.1. So let's plug that in. Negative 0.1, absolute value bar, and 4 times negative 0.1. So you get 0.1, negative 0.4. So you get negative 1/4. Okay, so now you notice on the right hand side, the limit was positive 1/4. On the left hand side, the limit is negative 1/4. So what's happening is that your function is not coming to the same value. The left limit, the left limit, and the right limit do not equal. Okay, because these two numbers do not equal, then that means there's no limit. There's only a limit when these two guys are equal. Left side and right side are going towards the same value. Okay, so that's an example of a no limit. All right, so try these homework on page 833. All right, have fun.